Does anybody remember what a parallelogram is? Or no? It is a shape. A four-sided shape, that's true. So actually that's the first thing that I want to write down is, I guess recall, but you guys should be writing this down. A quadrilateral, whoops, I spelled that wrong. Quadrilateral is just a four-sided shape or a four-sided polygon. Bless you.
I thought today was the 14th for some reason.
That's silly. Don't be silly. What 14th? That's a long time ago. Thank you.
Well, I wrote the 14th on a history test I took this morning, so that'll be fun.
Okay. And a parallelogram. So a quadrilateral is a four-sided polygon. A parallelogram is a quadrilateral with two pairs of parallel sides. So, some examples. Does anyone know a name of a common parallelogram? A square. A rectangle is a parallelogram. Remember, the only thing you need are two pairs. So the top and bottom is one pair. The left and the right side is another pair that are parallel. A pair that's parallel. Two pairs that are parallel. Two, as in a pair of parallel sides. And then a diamond that we can do something like this. Try and make them parallel. They'll also be congruent. I didn't put the parallel lines on the other ones because those are ones that we've seen before. Could you? Thank you. Yeah, we're not going to call this like anything specific because we didn't necessarily make all of the sides congruent, but that's the normal parallelogram that we're going to deal with. I'm going to tilt it to the right a little bit, but the first property of a parallelogram is that the opposite sides are congruent. So this is congruent to this and it's parallel. This is congruent to this and it's parallel. And that already happens for these parallelograms as well, the square and the rectangle. So I'm going to say properties of parallelograms. Opposite sides. Thank you. Properties of parallelograms. Opposite sides are congruent. So if I have this picture, I'm going to say best parallelogram that I can do. If opposite sides are congruent, what two segments are congruent? Like, what two pairs of segments? Raise your hand if you know. If you understand what this sentence means.
I'm so fat.
Kata?
Like the opposite, like that's why they have the little arrows.
Well, the arrows mean that they're parallel.
Oh, okay.
So, but I'm saying opposite sides are congruent. I'm asking for someone to name a pair of opposite sides.
B, C, and
Yeah, BC. So that means BC is congruent to AD.
Just look on the board. Tell them to scroll on.
And what else? What other sides are opposite? AB and DC, yeah. AB and DC, they're opposite each other. So AB is congruent to DC. So that's all that means. Opposite sides are congruent. So for this, let's say number 2. Opposite angles are congruent. They're not necessarily congruent to, like, all the angles are congruent. That's not true all the time. It is with a square and a rectangle, but if I say opposite angles are congruent with the same picture, that just means angle B is congruent to angle D. Well, that's in the video, I bet. Angle A is congruent to angle C. I would put the tick marks on, but I don't want to make it super, super messy. What about this? Let's see if we can get this part. So 3. We'll say same picture. I am going to fill this in. Consecutive angles are, and then I'm going to fill that in. But I'm going to see if you can guess this or remember this. The measure of angle A plus the measure of angle B has to equal what? Do we remember? We should. So what does it have to equal? Yeah, 180. Look, remember we have two parallel lines cut by a transversal on this side. So one parallel line here, one parallel line here, cut by a transversal. These are same side interior angles, so they have to add up to 180. So then I could say 180 here and supplementary here. What other two angles add up to 180 from this picture? So we have A and B. Say it again.
C and D.
Measure of angle C plus the measure of angle D equals 180. What else? There's more.
A, B,
A and D. Measure angle A plus the measure. Can you see that? angle A and D add up to 180. And the last one, measure of angle B plus the measure of angle C equals 180. As long as they're right next to each other, they add up to 180. This and this add up to 180, this and this, this and this, and so forth. Excuse me. Questions so far? I think we're almost done with the theorems that we have, and then we'll move on to the examples. Yeah, sign up, please. Uh, 34? 33? Questions? Can I move on? I'm moving on. So, we have that the opposite sides are parallel, opposite sides are congruent, and then consecutive angles are supplementary. The last property, number 4, will be that if you have a parallelogram, so let me draw that picture again. Without all that extra stuff, but actually the arrows will be there still. So we have all of that. The diagonals bisect each other. So I'm going to draw the diagonals here. The diagonals of a parallelogram bisect each other. The diagonals aren't necessarily congruent. Maybe you can tell, but this diagonal BD is shorter than AC, so the diagonals aren't congruent. However, if I call this middle point Z, then BZ, that's this, BZ, is congruent to ZD. And AZ, whoops, not equal, congruent. ZC. Hopefully that's straightforward. We can now get to the examples. So example 1, find each measure. Maybe we're looking at an angle. Maybe we're looking at a side length. But I'm going to give you a picture. This is a parallelogram. That's an angle 10y minus 1 down there. And we have 6y plus 5, that's also an angle. And then we have 5x plus 19 and 7x. Find the length of AD. And then part B is going to be to find the length, or find the measure of angle B. I'm going to let you guys try that for a second. Alright. On this first one, we're trying to find the length of AD. AD is this side. And since this is a parallelogram, because I told you at the beginning, since this is a parallelogram, I know that opposite sides are congruent. So that means 5x plus 19 has to equal 7x. It must. Those side lengths are going to be the same. So set them equal. Subtract 5x from both sides. 19 equals 2x. Divide by 2. X equals 9.5.
Yes.
But we are not finished because it's asking for AD. So I have to plug that back in. So 9.5 times 7, that's 66.5, right? So that's what the side length is for AD. We don't write the bar on top because we're talking about the length. Questions on that? I mean, it should be pretty straightforward. And then the measure of angle B, well that one, well this plus this, these are consecutive angles, so they have to add up to 180 degrees. So 6y plus 5, whoops, not equals, 6y plus 5 plus 10y minus 1 equals 180. Has to equal 180. And then I combine like terms. The y's are like terms. So 16y plus 4 equals 180. Subtract 4. 16y equals 176. And divide both sides by 16. Y equals, what is that, 18? 11, right? 176 divided by 16? 11. But remember, we want to find angle B, which means we have to plug it into this. So 6 times 11 plus 5 equals 66 plus 5, which is 71 degrees. I think we just have one more example. Oh, we got time. Questions on that? Pretty simple. Anyone need this still? Anyone still copying this part down? No? Okay, moving on. Thank you, Will. All right, this will be the last example. So I'm going to say we have another parallelogram. E, F, G, H. Draw their diagonals as well. The point where their diagonals intersect is going to be J. And I have 4Z minus 9, 2Z, W plus 8, and 3W. Find the length of JG, Wentworth. Find the length of JG and the length of FH. J is the center where the two diagonals intersect. And just to be clear, I should have written this on the other one, but E, F, G, H is a parallelogram. This will be our last example. So, on the first part, JG, that's this piece. So W plus 8. But I know that because this is a parallelogram, those two segments are congruent, so I can set them equal. 3W equals W plus 8. Because this is a parallelogram and those two things are equal, or congruent rather. Minus W to both sides, and I get 2W equals 8 divided by 2. W equals 4, but it's looking for JG, so I have to plug that into there. So then 4 plus 8 gives me 12, and that means JG equals 12. That one's pretty straightforward. Now FH is a similar way. I just set the two equal to each other. I would actually, what I want to show is a way to solve this. Normally, I think what most people would do is subtract 2z over, z, subtract 2z, and it cancels on the right side. So I get regular 2z minus 9 equals 0. That's what a lot of people don't do. They get confused because there's nothing over there, and they don't put 0. You should put the 0 when it cancels out. And then some people put the equal sign in between without changing it to a positive 9. So just be careful with that. So 0 on that side, then I can add the number over. And I get 2z equals positive 9 divided by 2. And that gives me z equals 4.5. However, I want the entire thing. F all the way to H. So I can find one piece, I can find the other and add them together, or I could just find one piece and times it by 2. So that's what I'm going to do. I'm plugging that into here. So I have 2 times 4.5, that's back to 9. And then 9 plus 9 is 18. You could plug it into this. 4 times 4.5 That's 18 minus 9 is 9. So we still get the same thing. So 9 plus 9, that's this plus this, equals 18. Last thing, FH equals 18. So we have both of our answers there. Any questions on that?